Okay, Frosty. Frosty, you had a good boy. You're a good boy today, huh? Today's a very nice day. Frosty's been out a lot, and he's doing very well today. Have another one of those bombs. Okay? Good appetite? Good. Now have another one. Okay, you're looking good, Frosty. You're looking good. Okay, today I wanted to do a little experiment about sampling for a poll. Like, let's say we're going to have an election and we want to take a survey or a poll to see who's going to win the election. And in this case, I'm going to assume that in this election, 50% of the people are going to vote one way and 50% are going to vote another way. So in this pot here, there's 180 total counters. Each one is going to be a person. I got 80 white ones and 80 black ones. Okay? And let's just say this is the presidential election for 2012. And let's say this is Chelmsford. And let's say 50% of the people are going to vote for Palin. And let's say 50% of the people are going to vote for Obama. But we don't know that ahead of time. We want to take a poll to find out how many of them are going to vote. So we have to go and ask a certain number. And let's say that that number is going to be, just to start off, we're going to try 10. We're going to pick 10 of them. So what I'm going to do is I'm just going to pick 10 of them out of here without looking. At random. The idea on a poll is it's supposed to be totally random. The more random it is, the better. So I'm just going to pick out some. I'm going to take 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 without looking at the color. And I'm going to look at it and see how we did. Now, in this one, I would predict, based on this poll, that Obama, 60%. Okay, because you get 6 out of 10. That's 20% margin. Now, we know the real answer here is 50-50. This actually represents 20% error in the poll. But the reason is because I only took 10 of them. 10 is not a very big enough number. So let me just try it again. Take 10 more. I'm not looking at the color, so it's pretty random. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10 people. I just surveyed them. Now on this one, I could do this like 1 week later. Now this one, oh my God, now Palin wins by 60 to 40. So it went from Obama being up by 20 points, now Palin's up by 20 points. All could have happened in 1 week or 1 day. So that's also a 20% error, though only that's in the other direction. So that shows you that that's a poll where you pick out 10 people. You might think that that's like maybe reasonable. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 5. Okay, that one came out 50%. This one actually didn't have any error at all. This was the correct number. But that you're going to get that less frequently than probably getting a mistake. 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh boy, look at that one. 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 7, 8, 9, 10. This one actually said that Palin's going to win 90% to 10%. Now that's just an extreme case, and I just did all those totally at random, but that goes to show you what sort of numbers you can end up with. 10 is totally too low, and ends up with errors easily 20, 30% error in your poll. You need to get a bigger number. Now, I'd love to be able to use a bigger number, but I just don't have enough beads. I only have 180 of them in here. I can't pick 100 of them out, for example, and count them up. That's not going to work. But what I did find was, I did find a computer website which had, it's called Simulated Coin Toss. Now, picking out one of these, it's like 50% chance of getting a white or 50% chance of getting a black. But, which is just like flipping a coin. In a race which is very close, where it's going to come out near 50-50, you can get the statistics of how large your sample size has to be by flipping a coin. So I'm going to do a coin flip on this computer program, and I'm going to flip 100 coins according to this, and I'm going to just push the button. It's going to say flip them, and this one came out 59 to 41. Okay, 59 to 41. That's actually a 18% error. Now I'm going to flip them again. This one came out 52, 48. That's a 4% error. Flip it a third time. This one came out, oh, did I hit it again? It came out 52, 48. I'm concerned I didn't actually flip it. I might have, but I'm not sure that I did. Okay, 56 to 44. That's a 12% error. So now the next one, flip it again. I got 57, 43. That's a 14% error. 55, 45. That's a 10% error. Flip it again. 47, 53. It's a 6% error. 54, 46. 55, 45. I'll do it one more time. 51, 49. Okay, now I'm assuming that this website that it's really getting a 50% chance. You never know for sure exactly how the program's running that generates the random number. This shows that you can easily get errors as large as, even as in this case, as large as like a 19% error, or most of the errors are smaller, more like 10% errors, something like that. It's still not going to be very useful if you did a survey of something where you needed, that was a close race. You need better accuracy than this. So what I'm going to do is I will, because it's very easy on this program, I'll just change it to 1,000 and see how that comes out. I'll flip this 10 times, see what I get. Now it takes harder to fill it up. Okay, first time through. 494. 506. Okay. Second time through. 488. 512. Third time through. 497. 503. Fourth time through, I got 500, 500. This one came 496, 504. 485, 515. 480, 520. 540, 460. 5 492, 508. Let's see, I'll do one more. That'll make 10 trials. 46 and 514. So you see the largest error here would have been, it looks like 54% to 46%. Even if you surveyed 1,000 people, you could come up with something which is off really by 8 percentage points. Now most of them are closer than that. Like the first one was only off by 2 percentage points. The next one was off by 2 percentage points. The next one was off by 1 percentage point. The next one was off by no percentage points. The next one was off by 1 percentage point. The next one was off by 3 percentage points. The next one was off by 4. Then this one here, 8 percentage point. That was really kind of like a whopping error. And then the next one was off by 2. And the next one was also by 3. So most an error, when they use about 1,000, usually the margin of error is usually somewhere around 3%. Or it's maybe when they use a couple of thousand. This little experiment I did is not very precise. It's only showing you that the number really has to be up into about 1,000 before you have an accuracy of a couple of percent. And even at this one, we got one here where the error was as large as 8% on something that was supposed to be totally 50% probability. So anyway, this is just a demonstration of that, and I'll give you a little appreciation for basically why a survey of like only did 10. It's not significant, not statistically significant. And even this 1,000, I think, is on the low side. I think when they actually do a poll, I think they shoot for numbers more like several thousand, or maybe just 2,000 or something like that. But 1,000 is like a rule of thumb. That's usually good enough. But you can see here that there's always room for just a statistical variation.